Hi, I'm Emily Hauser, and I'm going to be doing a problem from the electrochemistry unit. We are told to balance an electrochemical reaction using only whole numbers. We're going to write out the half reactions, say whether they occur at the cathode or the anode, and then calculate the electric potential of the cell. All right, so the equation we have is iron 3 plus aqueous plus tin solid goes to iron solid and tin 2 plus aqueous. So first I'll split it into half reactions. So we have the iron ion goes to iron metal, and the tin metal goes to the tin ion. All right, and then we need to make sure we balance the charge. So we need to add in the electrons. So here we have a +3 and neutral, so we need to add in 3 electrons on this side. And then here we have neutral and +2, so we need 2 electrons on that side to balance it out. But then we need the electron transfer to be equal, so we're gonna have to multiply this equation by 2 and this equation by 3. And when we do that, we can put the two half reactions back together to get our final reaction, and the electrons will cancel. So we need to make sure to distribute the 2. So we'll have 2 Fe3 plus aqueous plus 3 tin solid goes to 2 iron solid plus 3 of the tin ion. All right, so this is the fully balanced full equation, and these are the half reactions. And then we need to look at the half reactions again and say whether they happen at the cathode or the anode. So in order to do that, we need to know which is a reduction and which is an oxidation. So here we're going from 3 plus to a charge of 0, which means we're getting more negative, so we're gaining electrons, and that is a reduction. And reductions happen at the cathode. And then here we're going from a neutral charge to a positive charge, which means we're losing electrons. And when you lose electrons, that's oxidation, which happens at the anode. And then finally, we need to calculate E standard of the cell, and that is equal to the potential at the cathode minus that at the anode, both standard. All right, and we can look in our little chart of what these values are, and we get that for this half reaction, it is negative 0.036 volts, and for the anode, this half reaction, we get negative 0.14 volts. So then we just do that subtraction, and we get 0.10 volts. And that is our final answer. So to summarize, we started with the equation, we split it into half reactions and balanced the charge, and then we had to make the transfer of electrons equal for both. Then we combined them back into the final balanced reaction. We determined which half reaction occurred at the cathode and which happened at the anode based on whether it was a reduction or an oxidation, and then we were able to calculate this electric potential. Awesome. Thanks so much for watching.